Welcome all. It's M. Selvangadesh, a research scholar from Tyagarajar College of Engineering, Madurai, India. Before moving on to my work, I would like to start the simulation because it will take some time. In this intermediate time, I will start to explain. Okay, I started the simulation. It started to compile. Okay, let's move on to the explanation. For this MATLAB Simulink Challenge of 2025, I have came with an idea of simulating the active distribution system which is available in our college. Our college consists of 7 departments where each department has a separate building, in which I have taken the EEE block where I am doing the researches for my PhD. Our EEE block consists of many laboratories which has a capacity of consuming 80 kilowatt in an hour. When its peak, all the labs are in active stage and as well as all the classes. So I have modeled them in as a three-phase RL block which consists of 80 kilowatt of consumption. And at the same time, in our college, we have the rooftop panel capacity of 80 kilowatt. I have replicated them by using the PV array, which consists of 539.5 peak rate of module, which is connected in series of 15 modules, and as well as the 10 parallel strings. It can provide about 80,925 watts in at a peak voltage of 622.5. Basically, the people will do on consuming the irradiance and temperature as a constant one, but we are not going to do that. In our college, we have a PV monitoring system. I have utilized this and then taken a data for May 31st. It consists of many hours. I have grouped them into 24 hours. By using that 24 hours, I have taken only about the 15 hours, which is the sunshine period where the generation is going to be happen. But by using the repeating sequence interpolated block, I have given that 15 points and as well as the 15 time zones. Correspondingly, the temperature is also given like that as an input for the PV array. When that 622.5 only available in its peak condition, but it will not be a safer side when moving on to the three-phase inverter in order to connecting it with the existing grid of phase-to-phase voltage of 440 volt and 50 hertz, because the synchronization is very important in on-grid PV system. In our college, it consists of not a separate controlling system for the inverter, but the technique is also be using for the boosting the voltage is also be very old technique. So only I have made a PTAP and PO advanced method for making a boosting of voltage. For in order to maintain the safe AC synchronization, we are maintaining the DC link of reference of 800 volt. For that, we are making a DC to DC boost converter, which is where the trigger signals are given by the MPPT PO boost subsystem technique that consists of this function block that we are going to use this formula. From that, the PV voltage and as well the current is going to be feed, and the clock signal is also be given, and it is given to the saturation point and rate transition. From that, the PWM generator is going to the signal gates. At the same time, when the voltage has been improved by to 800 volt, this signals the three-phase inverter also needs a signal. At the same time, the PCC measurement, which is the measurement which is taken from the grid side, this by utilizing that we are moving on to the spring PWM and Technica. From that, the signals are going to be a reference of 800 volt and as well as the PV grid 440 volt. We are making a signals by using the um, PWM generator. From that signals only we are going to modulate it, so that the by using when crossing this L filters of all the three phases, the technique will be goodly synchronized. From that, the EB block can be benefited so that the grid import can be reduced and as well as the PV consumption is increased. You can see that when MPPT, the consumption, the power production is also be happened at the same time. When moving on to the voltage, you can see that the voltage also be improved in both the conditions in grid and as well as the PV. And then when consuming power, you can see that the grid power maintenance is also be greatly maintained as well as the power consumption in the PV is also be greatly maintained. You can the PV has been consumption has been flattened as well the grid has been flattened. There is no extra peaks and sudden peaks. Therefore, my technique has been achieved here stability. This is the active distribution stability improvement project that I have been implied by using the MATLAB. Thank you for the chance of giving an opportunity.